speaker will be Dr. Gunter Ziegler. He is professor at Free University, Berlin, Germany. He is also past president of German Mathematical Society and directs their media office. And he is author of lectures on polytops of proofs from the book, as well as of popular books in mathematics, like Stories from Mathematics. This is translated into Korean too. And his title will be the Teaching and Learning What is Mathematics. Please welcome him.
Let me try and do it this way. Thank you very much for this introduction, and also congratulations for getting my name right. I know this is difficult. So this is the education and popularization section, and I guess I have sort of the education part in this. So my lecture will be teaching and learning what is mathematics, and I've also come here, just like Etienne, to basically ask a question, not because I believe I know a complete answer. And also because of that, I want to mostly share personal opinions and experiences and approaches. And I believe that also no one has a complete answer, and I also believe that there isn't the one approach that will solve everything, but it is necessary from many different directions and from many different approaches to get into these things. Now, my lecture will have two parts, and the first one will start with this question: what is mathematics? And as I said, I don't have a complete answer, and I believe you don't either, but if you do, please tell me. I'll show you a few more details of what I expect.
So you should begin by definition.
I will begin by definition, of course. And you will realize that this is complicated enough, but while I still do my table of contents slide, please think about your own definition. If I asked you, or someone asked you, mathematics, please define what is mathematics, which answer will you give? And this will have a few sub-questions. So my points here is I will start with, it's here called descriptions, but indeed if you want to formalize Bourbaki style, it will be definitions. I will talk about panoramas. You will see that I'm a geometer, so my approach will be image-based. I will talk about images, and I believe that the human factor is important here. This is not only the title of one of my favorite novels by Graham Greene. And then the second part of the lecture will be on teaching and learning what is mathematics. And again, this will have 4 bullets, and the first one will be starting with Felix Klein, and I think 3 is sort of a magic number, Etienne, so I will share with you 3 personal experiences, projects, approaches. So what is mathematics? As you know, there's a famous book by Courant and Robbins. This is the title of the 5th edition in German, which has this title, Was ist Mathematik? What is mathematics? And if you go into it, if you start with the preface, it does give rather interesting and important aspects, but actually doesn't answer the question. So what it does, it says here mathematics is an expression of the human mind, reflects the active will, the complexity of reason, and so on. And its basic elements are logic and intuition, analysis and construction, generality and individuality, and so on. So it gives lots of interesting aspects of mathematics, and there's lots of them. That's sort of the first observation. Then one paragraph down, and of course because this was Richard Courant, he says that all mathematical development has a psychological roots in practical requirements, and so is motivated by applications. I would believe that's also an important aspect, but it's not the sole definition of why we do mathematics. And then at the end of the preface, there comes the sentence which says, for scholars and laymen alike, it is not philosophy but active experience in mathematics itself that alone can answer the question, what is mathematics? So the Courant-Robbins answer is that you can learn and experience what is mathematics only if you do mathematics yourself. If you now believe that teachers at high school who teach their kids about mathematics also have to give them an image of what is mathematics, then this is the reason why we send the teachers to university to study mathematics, more or less successfully. And the question is whether they get from that experience which they have there, which typically is not a full-fledged research experience, whether they have a broad image of what is mathematics from that experience. We will get there. But first, let's try again with what is mathematics. Of course, if you need a definition and if you don't want to think about it yourself, then you ask Google, and Google says, ask Wikipedia, and Wikipedia says this. Mathematics, often called math or maths for short, is the study of topics such as quantity, numbers, structure, space, and change. There's a range of views among mathematicians and philosophers as to the exact scope and definition of mathematics. Note, this would have made this Viennese Jewish mathematician Kurt Gödel very happy to see that part of the definition of mathematics is that there's no agreement about what the definition of mathematics is. Right? And then it says mathematicians seek out patterns and use them to formulate new conjectures. They resolve the truth and falsity of conjectures by mathematical proof, and so on. Is this our experience of what we do when we do mathematics? I think none of this is wrong, but it's definitely not a well-rounded picture. And if a teacher in high school is supposed to sort of give an answer to what is mathematics, this doesn't really give you the right thing. Of course, Wikipedia exists in many languages. And you may be happy to hear that I report that Wikipedia in German, of course, is much worse. So here's the first paragraph. Here's my translation of the first paragraph. Mathematics is a science that developed from the investigation of geometric figures and the computing with numbers. For mathematics, there is no commonly accepted definition. That's the Gödel part. Today, it is usually described as a science that investigates abstract structures that it created itself by logical definitions using logic for their properties and patterns. That's not what got me into math. That's not what I'm here for. And if this is just to study stuff that we've created ourselves by logical definitions, just definitely doesn't say why this is supposed to be interesting in the first place. Right? So this is a very limited definition. So what is mathematics? And I'm just trying to give you sort of a few different approaches to getting there. So I think the reason why Wikipedia fails there, and others fail as well, is that mathematics is actually a bunch of different things which all come under this headline. And sort of semi-jokingly, I have claimed, and this has been published, that one mistake we have in high schools is that there's only one subject called mathematics. We need at least 3. Of course, other subjects won't like this, but mathematics is actually a toolbox for everyday life. Mathematics is also a part of our culture, thousands of years old. That's a completely separate thing. Well, it has to do with each other, of course. And it also a basis for high tech and an essential such basis. This is three completely different things. And we can argue with our school boards whether this means we need 3 subjects. Of course, this is joking, but indeed, all these 3 aspects need their space in the curriculum. And if we just teach one of the 3, then this will not be the whole thing. And you know, if you don't get this across as part of our culture, then this will not be enough motivation to studying. And this reason that we need math because it's high-tech motivates one, but it doesn't motivate the other. So there's many aspects of this. Okay. Let me go for a completely different attempt to answer the question via panoramas. I was, a few years ago, I was at a department store in Berlin, and, no, just one step before this story. A study from England a few years ago which described that the students' view, so this is advanced high school students they studied, of mathematics included narrow and inaccurate images that were often limited to numbers and basic arithmetic. So the view of what is math with many students that comes across is the subject that they did in high school, right? Arithmetic, geometry, and so on. That's the study from 2008. So I was in this store in Berlin, and I saw there's a bookshelf with these Was ist was books, which I had as a kid. And volume number 12 was mathematics. And I took this volume from the shelf and thought, oh, interesting. This is not the cover I remember. I'm showing you this cover because, so this is a series of books for high school students. It's supposed to attract them to various topics from dinosaurs to the weather, and physics and chemistry and mathematics. And here in one picture, you have a representation of what math is about. This is supposed to show many aspects. Some of them come up in the book. And you can now think of, is this a reasonable representation of mathematics? Now, it's not the cover I remember. So when I was back home, I asked my mom whether these Was ist was books are still around, and she said yes. Your nieces and nephews somehow don't look at these books. So I got it, and it looked like this. This is the 1963 edition. And it turns out that these books, actually, this is a series that originated in the US, early 60s, and they were called the How and Why Wonder books. And this is the cover of the US edition from that time. And this book here was a translation into German. This book series, Was ist was, was much more successful in Germany than it was in the US. In the US it somehow died in the 70s after 60 volumes. In Germany we have 150 volumes by then, and they're still active. And every few years they change the cover. And so this is a cover from the 1980s. Tom, here this Mobius, this two-colored Mobius band is for you. There's a later printing of this where the Mobius band was all green then. So, you know, also this is 1980s where they suddenly decided that the most interesting thing in mathematics, of course, is set theory, intersection, subsets, all that stuff. So I added a few pages on that and cut out the math and space travel instead. Right? This is the current version of the book, 2010. So here you have the 4 covers in German, the major ones that were around. This is actually 2 different books. So the first, the 2 on the left and the 2 on the right is essentially the same book but with different covers. This is 4 panoramas of what math is about. Things from math and so on. I won't discuss them in detail now. I mean, the exercise for you would be to design your own cover. If you get one poster of what math is about, you know, there's various ways to do it. And I mean, the first one here, this is math as a historical discipline. And this is still the ancient Egyptians, but there's also space travel, and there's of course the dikes and so on. So this is representations. That's what I call a panorama of mathematics. None of them give it all, but I think they're interesting attempts, and I think sort of to give an image for what math is, this is an approach. I think that images are important for communicating mathematics, and they are also a chance to do some storytelling. So this, for example, is an image I like a lot. It's from a protest demonstration in Moscow against the election results in 2012. And this guy holds up a poster which means we don't believe Churov, we believe in Gauss. That's math in public. So, and then there's a graph which is supposed to prove that the election results were forged. And actually, so who is Gauss? Perhaps I don't have to tell you, but for us Germans, Gauss used to be rather real, because this is the Deutsche Mark, 10 marks bill until the euro came. And again, I'm not talking about sort of abstract stuff. This is how this bill looked like. One thing you might notice is that actually he's the wrong way around. This is the original portrait. So this is the Gauss they talk about. Anyway, this is the Churov they talk about. He's the head of the election commission in Russia since a number of years, and he had promised to shave off his beard if there was anything wrong with the elections. And this is the graph. So this is math in public, trying to prove something. And only very quickly, this here graphs from 0 to 100 in half% intervals from how many election districts a certain percentage was given for a certain party. And this, of course, is Putin's party. And there's a bunch of things which are rather strange. You would somehow expect something like a bell curve, Gauss, you know. This is not bell, and it all these peaks in there. Like apparently, you know, these round sort of 80, 85, 90% were much more frequent than 81, 86, 91%. That's one thing that gives it away. This huge thing over there, of course, also gives things away and so on. So this is sort of proof that the elections were forged. And this was very popular on LiveJournal, which is the Russian version of Facebook, immediately after the elections. And it was on various posters, both in Moscow and St. Petersburg, and probably elsewhere. You could go into, I mean, this is the statistics. It turns out that this 50% thing here is actually a statistical artifact, so it was a mistake by the people who did the statistics in some sense. This just comes from the small election districts. You know, if only 10 people cast their vote, then 50% is actually quite probable and 49 is not. That's where this peak comes from. And if you correct the graphics, it looks like that, and you still see the other peaks are there. So this is sort of the scientific basis of what I'm presenting you here. So this is Dmitry Kovac, Sergei Shpilkin, and Maxim Pshenichnikov, who presented their analysis later on the archive, but immediate after the elections on LiveJournal. And that's the three of them, Sergei Shpilkin, Maxim Pshenichnikov, and Dmitry Kovac, who did the analysis. I think this is sort of stories on the popularization part, but you see it started out with math in the public trying to prove something. I think the human factor is important, and these definitions from Wikipedia miss that. Math is a human activity. If you go back to this British study that I have been quoting, then they say that many students seem to think of mathematicians as old, white, middle-class men who are obsessed with their subject, lack scope and social skills, and have no personal life outside maths. This is a disaster because a gifted 17-year-old who thinks about what she could do when she goes to university, under this image is not going to decide, I want to be a mathematician. And the second part of the diagnosis is that, of course, this cliché comes from what's presented in popular culture. Okay, so what is mathematics? I have shown you these three parts. There's the fourth part, which says math is a human activity. And that's an important part of it. And that also means if you present an image of what math is, then you have to present the humans. Here's one of my favorite parts of that. This is one of the usual, you know, these newspaper reports saying that girls can do math as well as boys. In this case, this is 2008 on Spiegel Online, which is a major news website in Germany. And I was interested in this because I thought I had seen this photo before. A little girl in front of a pocket calculator. Now it turns out that, you know, if you ask Reuters for an image of math and girls from their database, they'll offer you this one. So I wanted to know what's behind this image, you know, who is our poster girl here? This is a girl in front of pocket calculator. Stereotypes are very resistant against change. That's true, even if they got the wrong plural of stereotype in there. This is this image. And the fun thing I had is I tracked down the girl. Because if you go to the JPEG, which is on the web, you can read there here the original story, and you find out the image was 10 years old. It's from 1998. And this is from some conference in Manchester where School Standards Minister Stephen Weyer said something. From that you will find out which year this is. And it also says the name of the girl. Her name is Sarah Sherry. So I wrote to the Beaver Road Infant School, didn't get a reply. And then I did something I usually don't do on some Tuesday morning while working on a book project. I wrote a message to like 10 girls or women on Facebook that I didn't know. And asked, are you the girl in the image? And I waited from Tuesday to Sunday, and Sunday evening I got a reply from this girl here, which said, I am the Sarah Sherry in the photo. I vaguely remember the photo being taken while I was in infant school. What do you want to know? I said, I want to know whether you were good at math in school. Was this fun? How is it? And the short answer is yes. She's a student of material science and engineering at Manchester University now. So this is a good poster girl for you know, this is the human factor, and I think it's important if we give an image of what is mathematics. This is Sarah Sherry today. She's 20. Okay, this was the first half of my lecture. The second half will be about how do we get this sort of transported. And of course, popularization is one part of the story, and that's not the one I'm talking about today, at least only partly. But we also have to think about what we do specifically to get this into the schools. And for that, I want to first present you with a diagnosis which is rather old, but unfortunately still valid. So Klein is Felix Klein, who may be the most important mathematician ever, who in math history who never made it onto a stamp. So this is sort of a privately designed stamp, which you can, apparently, at least in Germany, you can sort of create stamps yourself via some website, and they're valid. Anyway, this is not mine, just found on the internet. At the beginning of his, so this is the diagnosis. At the beginning of his university studies, the young student is confronted with problems that do not remind him at all of what he has dealt with up to then, and of course, he forgets all these things immediately and thoroughly. It's he because this was written 100 years ago. He or she would be correct today. When after graduation, he becomes a teacher, he has to teach exactly this traditional elementary mathematics, and since he can hardly link it with his university mathematics, he soon readopts the former teaching tradition. and his studies at the university become a more or less pleasant reminiscence, which has no influence on his teaching. So, and this is what Felix Klein called the double discontinuity. You forget the school math when you get into university, and you forget the university math when you go back to school. And a lot of that in most countries, my guess, is still valid, unfortunately. And if you combine this with the Courant-Robbins diagnosis, which says the only way to experience what math is to experience doing it, then this research experience from university or whatever the teacher-student gets there, which is not transported down to the school, doesn't solve the problem. So we have a major problem there, and there's no easy solution, otherwise this might have been solved a long time ago. In Germany, one of the initiatives we have as of 2 or 3 years ago is this German Center for Continuing Teacher Education. So this focuses on courses and things for people who are already math teachers, where the diagnosis is, if they are 25 or 28 when they go to school, and then stay teachers until they are 65, this means 40 years of teaching, and in these 40 years the subject changes dramatically. I mean, math today just isn't what it was 40 years ago, of course. And that's sort of one of the German initiatives which I think is very valuable and making progress. But I want to tell you about one project I'm working on myself, together with Andreas Loos, who's also co-author of my paper, who happens to be a trained math and physics teacher, who also happens to have a PhD in math now, and who's also an educated and learned journalist. And these people are not so easy to find in that combination. And what we are doing is a project that we call Panorama of Mathematics, which primarily is a university course on the curriculum at Freie Universität, trying to teach what is mathematics in sort of a rounded way. And we're also working on a book and web materials and so on in this connection. And this here is, so the book is supposed to be out next year, not this one. This is basically the table of contents. So you see, we start out with what is math in various ways. There's sort of concepts we talk about, that's sort of still key concepts in mathematics. But there's also a section on computing and algorithms, on images, about math and the media, about trends, and so on. Now comes the quiz part. I hope you're ready. Teacher in school will have to face sort of stupid questions. There's no such thing as a stupid question, but you'll have to answer the question yourself. And here's just a list of questions about, I hope you've prepared your definitions, questions about what is math. And here's question number 1, when did math start? I have a whole bunch of questions now. I think we don't have very much time, but you want to give me quick answers. I've sort of prepared sort of quick and incomplete whatever answer. So when did math start? Here's a possible quick answer. Numbers and geometric figures start in Stone Age. The science starts with Euclid. People from India might disagree. This is incomplete answers, but it's sort of a first attempt as a quick answer. Not more than that. How large is mathematics? How many mathematicians are there? Have you ever thought about this question? I think it's a relevant question, you know. The question we get, of course, is there anything left to do, and haven't all numbers been computed by now? If you want to talk about mathematics as a subject, then, you know, how large is it? How large is it compared to physics, whatever? Right? And it's not so easy to quantify that, but there's various things you can do, and you can check. One thing you can do is you look at the Math Genealogy Project, and as of 4 days ago, it had 180 and something thousand mathematicians in the database. That's actually quite a large number of people who got a PhD. Most of them. That's sort of the people on the top of the roof who always don't have them. So it's a large subject, but of course, you know, how many mathematicians are there in your country? Who do you count as a mathematician? This is sort of people who have a PhD. Do you count the teachers? How many are there? Right? I think that's how large is the subject is an interesting question. How is mathematics done? What is doing research like? How does it feel? Of course, you can follow Coe and Robbins and read the book. They show you some math, so you can see a bit of that. Another approach would be look at autobiographical evidence. Recent examples, Ed Frankel's or Cedric Villani's books. Just one possible way to try to start and answer that, rather than telling you you have to do research yourself to know. What does mathematics research do today? What are the grand challenges? That's sort of coming after, isn't everything done already? The millennium problems, of course, give you one indication, but you know that this is very narrow, and actually very few people, even at this Congress, are just actively working on one of the millennium problems, I guess. How many subjects and subdisciplines are there in mathematics? I mean, in high school I had these books, algebra and geometry. So this might get you, or then there was at some point there was some probability and there was calculus. So is this the 4 parts of math that we have? Or is there something else? I mean, I don't have to ask you. But I mean, how many subdisciplines are there in math? Look at the Math Subject Classification Index 2010 version. It's over 5,000 subdisciplines. That's quite a lot. Right? So one way to quantify this is a large and diverse subject. Why is there no mathematical industry as there is, for example, chemical industry? Answer, of course there is. Telecommunications, financial industry, of course this is mathematical industry. So, what are the key concepts in mathematics? Do they still drive research? Well, what Wikipedia has there, numbers, shapes, dimensions, infinity, change, abstraction, this is all things that drive research. Yes, they still do. But of course the list needs to be extended. What is math good for? Sort of a naive question, but teachers know that question, and some of them are afraid of it. This is a short answer, but you want to somehow give details. Where do we do math in everyday life? There's answers to that. Where do we see math in everyday life? I mean, a quick answer might be there's more math in every smartphone that anyone learns in school. Actually, there's also more math in every smartphone, or in most smartphones than, or in smarter smartphones that anybody learns in, single person learns in university either. What are the greatest achievements of mathematics through the history? Make your own list. So, this is sort of questions that probe what kind of subject is it, how large is it, what do people do, and so on. And I think we have to, and that's part of the Panorama project, is trying to give answers to these questions. This is what the book will look like. So this is draft version. So there is an early chapter about what is mathematics. And then there's a graph. This is the graph of how the number of papers indexed on Zentralblatt grows with time. And up there is sort of how many papers are there in various subjects in Zentralblatt. So that's one way to quantify mathematics. There's a chapter, how about doing, what is doing mathematics, starting with a portrait by Erdős. There's where does math come from, where is it going, that's the historical chapter. Math and the others, that's about applications. There's a chapter about images and so on. Okay. That's the Panorama project. I'm telling you that because I think you should try and do your own Panorama project, not because I believe that mine or ours will answer the question once and for all. And I think there's need and space for many of these projects. I've been trying, of course, to answer this question, what is mathematics, in various ways to various audiences. And two things I just already presented to you are from what I could call my images project. It's a little book that came out in German. It's called Mathematik, das ist doch keine Kunst, which has two meanings as a title. And it gives 24 pictures, and for these pictures, it gives the story. So this is what this little book looks like. And it's chronological, so the oldest chapter starts in -2000. That's the story of the Shango bone. And the latest chapter is in 2012, is this Gauss in Russia image. So this is how chapters then look like. 1933, I start with this book cover. I don't know if you've seen the book. It's an amazing book cover because this is a biography of Emmy Noether for younger readers. And the quiz question is, who's the lady on the cover? You can ask me later. It's not Emmy Noether. This is about these covers of the Was ist Was volumes I've shown you. And for this I talked to the designer of the latest version from 2010. I have a chapter about this photo and where it came from. If you might remember, if you were in Hyderabad 4 years ago, no, this was 8 years ago in Madrid, right? There was this awful mugshot photo of Perelman around, which was the only photo that, that the IMU had available. This actually is an amazing photo of a very interesting person, and taken by George Bergman in 1993 in Berkeley. He's the guy who photographs all the incoming visitors and faculty and stuff. Has this amazing photo collection, which you can access via the Oberwolfach Image Library, and that's where this photo is from. And there's the story of the girl with the pocket calculators. There's the story of this image, which is the first page of the patent for Google PageRank. This is about some really stupid advertising by a major German bank. And this is the last chapter about Gauss in Russia. That's the book. And another project which is not on images but on stories, which I think I will basically skip, has just one chapter, which I guess is still my favorite chapter, which just tells stories about interesting places where math is discovered. On the beach is a very important one, if you remember the story about snail on the beaches of Rio, but we'll get to see them in 4 years, I guess, and try them out. Including the internet as one of the places where math is done. So another chapter in the same book called Three Legends. I think history of mathematics is important. We have to include it. Giancarlo Rota, who was one of my teachers, has written that history of mathematics has a tendency to become gossip. And I know that he definitely did appreciate gossip of all forms. So this is not saying we shouldn't go into it. So this is sort of the stories project. That's the book you mentioned. That's indeed available in Korean, Italian, and Czech as well. Anyway, so this was my tour through what is mathematics. As I said, I'm going through personal experiences, and my point is not to tell you what it is, but to tell you you should start and work on making that visible. And the second part of the story was how do we transport them, and the main message there is we have to transport it to the public as a comprehensive multi-images view, but also, and in particular, we have to teach the teachers. And that's the end of my presentation. Thank you very much.
Now, time for questions. Still, I think, a couple of questions.
So what is the French definition of mathematics in Wikipedia?
look it up. And if you think it's not as good as it should be, considering the French academic traditions, improve it. If you want to have an extra homework, I looked up, there's Beauty of Mathematics. Has a web page, I think, in 8 or 10 languages. I think it includes French, it does not include German. And again, look at whether you like it and whether you think it's appropriate, and otherwise change it or improve it or add it. And the same for all the other languages where you can do that, from Russian to Hebrew and Indian, whatever languages. I think we know that the internet is a medium, and as important medium, and what's presented there as the homepage of math, and also for Beauty of Math, I think is important, because people look at that and they use that.
You said which definitions you didn't like, but actually you didn't give us your one-line definition.
I don't have one. My main line is there that I need at least 3 lines which would contain these 4 bullet points. And I think that I won't accept the definition which doesn't say math is this and this and this. And the reason is also to motivate people. I know that, you know, I was drawn into math because it's so hard and I love the competitions, and that was my way into math. And there's other kids who want to do something that's eventually useful. And the fact that math can be applied and so on is what draws them in. They want to do something that, and so on. And the fact that it's beautiful and has this cultural tradition is also something that draws people into math. And I think that's the 3 things that belong together. End of the line.
There is this seeming impression of the intrinsic difficulty of mathematics, which makes it kind of unpopular to the general public. So how do we address that issue?
2 answers. One is, I think we have to be honest about it, and math is difficult, and this thing, you know, I explain it to you, then becomes all easy, is a bit just not true. But the other point is, again, we have to then say, sorry, which math are we talking about? And I claim math is the hardest subject in the world if we talk about try the Langlands program. But if we talk about arithmetic as taught in 1st grade to 6th grade, you know, of course every kid can do it. I mean, it's hard, and it has this intrinsic thing of everything's either right or wrong, and nearly right is the same thing as wrong. But that's also part of the beauty, and that's what we have to be honest about. But we have to differentiate between, you know, the elementary math in school, which every kid can do, and where the kids need encouragement. And, you know, the real hard stuff they can strive for. And for that, of course, as we know, you need talent, and you need stamina, and you need encouragement, and a lot of things if you really want to do a research career in math.
Yes.
I always liked mathematics as patterns and relationships. What's wrong with that?
I think
it includes 1st grade and Langlands.
Yeah, yeah. There's nothing wrong with it. I think that's nice, except it needs explanations and detail, and then we're back to yeah. Thank you very much.
Yeah, okay.
As a sign of appreciation, the LOC has a gift for the speaker.